Hello, everybody. Welcome to section 1.4. This section is on rational expressions. So first off, what is a rational expression? So a rational expression is a fractional expression where both the denominator and the numerator, oops, not number, numerator, are polynomials. So for example, you might see something like x squared plus like 2x minus 3, and then that's going to be over, like, say, 4th x to the 4th, and then like minus 3x plus 2. This is a rational expression. So the first skill that you need to know for rational expressions is simplifying them. So simplifying. So let's see an example of simplifying. And it has a lot to do with factoring, actually. So let's say we want to simplify x squared minus 4 over x squared plus x minus 6. Well, first, you might notice this one is a difference of squares, right? So we have x squared minus 4 is equal to x squared minus 2, okay, and then we have x plus 2. Cool. And then for this one down here, we're going to use the AC method to factor it. So we want some number in blue, some other number in red, and we want their product to equal A times C. And for this one, A is 1 and C is negative 6. So 1 times negative 6 is negative 6. And then we want something, we want two numbers who add up to B, which in this case is just 1. And if you do a little thinking, those numbers turn out to be negative 2 and 3. Cool. And then the AC formula gets us that that polynomial factors out into x minus 2 times x plus 3. So then once we have these two factorings right here, we can rewrite the fractional expression. So we have x squared minus 4, and then we've got x squared plus x minus 6. We can rewrite that as x minus 2, x plus 2 for this top one, and then on the bottom it's going to be x minus 2, x plus 3. Now, we see that we've got a copy of x minus 2 on both the top and the bottom, and that means that we can just kind of cancel them out. Now you have to be careful because this only works because we have this multiplication here, right? If this instead were addition, this wouldn't work. So we can only cancel because multiplication. But then that means that we can simplify this expression down to x plus 2 over x plus 3. Cool. So simplifying is pretty nifty as long as you know how to factor. The next skill that you're going to need to know is multiplying and dividing them. And the rule here, multiply, divide. And they're grouped together because if you have some fractional expression like a over b, so like polynomial a over polynomial b, and you want to divide it by polynomial c over polynomial d, that's exactly the same thing as doing a over b times d over c, right? So when you want to do division, you're just going to flip these two and you're going to get multiplication. So they're kind of the same skill. Multiplying, dividing, just the same thing, as long as you remember this rule right here. So let's say we divide and simplify. why don't we do x minus 2 over x squared minus 9 divided by, we've got x squared plus x minus 6 all over, let's do 2x squared plus x minus 15. Now, following this rule that we have right up here, we can write this as x minus 2 over x squared minus 9 times 2x squared plus x minus 15, and x squared plus x minus 6. Okay, cool. So to multiply two rational expressions like this, it's easiest to go ahead and factor each of these first. So x minus 2, that's just a linear factor, so that stays the same. And then if you look, x squared minus 9 is a difference of squares, so we get x plus 3 and then x minus 3. And then times, so all that is times. And then you can go ahead and factor both of these using the AC method. And eventually you'll get that this top one is x plus 3 times 2x minus 5. And this bottom one turns out to be x minus 2, x plus 3. And you can go ahead and confirm that yourself if you'd like more factoring practice. And now we can look at some factors and we can cancel. And we can cancel because we've got that multiplication there, right? So we see an x minus 2 factor here and an x minus 2 factor here. X plus 3, x plus 3. And those are all the factors I see. So when we go ahead and write the answer out, we have 2x minus 5 over x minus 3 and then x plus 3. And then if you go ahead and if you want a complete answer, you have to FOIL those there. And so what you'll get 2x minus 5, and then over, we're going to get x squared for this first blue line here, and then plus 3x for this second blue line, and then minus 3x for this green line, and then minus 9 for that second green line. So you get 2x minus 5 over x squared. Those two cancel out, minus 9. You've noticed this is also a difference of squares, and you could have just jumped straight from there to here if you noticed that, but it's also okay just to FOIL it out and double check. So that is multiplying and dividing. So just to recap, you see a division, you flip it over to multiplication, and then it's best to factor, cancel out terms, and then go ahead and redistribute, and there is your final answer. Okay, cool. Now, adding and subtracting. Is actually harder, harder than multiplication and division, because, warning, you can only add or subtract rational expressions that have the same denominator. Okay, so let's say you get something like x plus 2 over x minus 1, and then you want to add it to like 3 over x minus 3. Now the problem here is that we've got an x minus 1 down here and an x minus 3 down here. And so we can't just go ahead and add these together and call it a day. We have to finagle around and do some black magic voodoo witchcraft stuff to try to get them over the same denominator. And the way we're going to do that is I'm going to take this first one here, x plus 2 over x minus 1, and I'm going to multiply it by fancy 1. I'm going to multiply it by x minus 3 over x minus 3. And that way, when I multiply these out, I'll get an x minus 3 term in the bottom. And for this one over here, I'm going to do, it's 3 over x minus 3, and then I'm going to multiply it by another fancy one, and I'm going to do x minus 1 over x minus 1, because that way I will have an x minus 1 factor in the bottom. And so if we write these out a little bit clearer, so we have x plus 2, and then x minus 3, and then we've got plus, and so this is over x minus 1, x minus 3. And then this is 3 times x minus 1, and this is x minus 1. I'm just going to move this one over to the other side of that one for clarity, and then x minus 3. Now, you'll see they have the same denominator right here. See? Yeah. Now we can add them together. So now we can do this. We can do x plus 2, x minus 3, and then plus 3x minus 1. And that's all going to be over x minus 1, x minus 3. And then for a complete answer, what you'll do is you need to do this addition up here, this polynomial addition. So we're going to go ahead and, we're going to go ahead and FOIL this out here, like that. So you're going to get x squared, this first blue line here, plus, or sorry, not plus, it's going to be minus 3x from the second blue line, and then plus 2x from this first red line, and then minus 6 from the second red line. And then from this one, we're going to distribute the 3 in, so we'll get plus 3x minus 3, and all of that is over x minus 1, x minus 3, and then that's going to be equal to combining like terms. There's only one x squared term, and then let's see, there's 1, 2, and then 3x terms, and so we've got minus 3x plus 3x. Those actually just cancel out, so we get plus 2x, and then we've got these two constant terms, which give us minus 9 over x minus 1, x minus 3. And if you leave things in this form, like this, that's fine. That is a complete answer in my book. I just don't like it when you've got like these things multiplying and then you're adding, and then that should be simplified. But if it's just linear factors, or if it's just linear factors multiplied together, that's okay. So this is good. All right. Now let's switch gears a little. Let's look at something maybe a little scarier, but still tackleable. Let's look at compound fractions. Knowing how to deal with compound fractions is actually very useful. And so compound fraction maybe like looks something like this. So let's say we wanted to simplify something like 1 over x plus 3, and then minus 1/2, and then all of that is over 5. How the heck do we do that? Well, let's do it in steps. So in this box here, first, what we're going to do is we're going to simplify the numerator. So we're going to simplify this top part right up here. Okay? So this top part is 1 over x plus 3 minus 1/2. Now we've got to make sure the denominators here are the same, right? So this 2 is not the same as x plus 3. So what I'm going to do is I'm going to multiply this one by 2 over 2, fancy 1 over x plus 3, and then times 2 over 2. So that's going to have a 2 factor. And then, oops, not plus, minus. And then this 1/2 here, I'm going to multiply it by x plus 3 over x plus 3 to get that x plus 3 term there. So then what this will become is we have 2 over 2 times x plus 3 minus, this is x plus 3 over 2 times x plus 3. And then what we get is we have the same denominator now. That's good. So now we can write 2 minus x, and then be careful. This minus sign is going to distribute in to the entire numerator. So this is 2 minus x minus 3 over 2 times x plus 3. And then if we simplify those terms right here, we get negative x minus 1 over 2x plus 3. Cool. So now what we can do is we can go back to our, so this was our first step right here. So now we can go back to our original expression. So we have 1 over x plus 3 minus 1/2, and that's all over 5. It's not a very nice 5. It's all over 5. And then what we're going to do is we're going to replace the numerator on top with the thing we just calculated. So this becomes negative x minus 1 over 2, and then x plus 3. And that's all over 5. And so this 5 down here can be thought of as 5 over 1, right? So this becomes negative x minus 1 over 2x plus 3 all over 5 over 1. And why did I just do that? Because now we're dividing rational expressions. So then this becomes, just to see it more clearly, divided by 5 over 1. And if you remember our rule from earlier, this then becomes our numerator thing times 1 over 5. And now this is just a simple multiplication. It's negative x minus 1, and then this 5 multiplies the bottom. So it's going to be 2x plus 3, and then times 5. Technically, this is all also times 1, but anything times 1 is itself. So for a final and complete answer, I'm going to combine these 2 times 5, so that's 10, and then x plus 3. Cool. All right. There is one more topic, and some of you actually asked about this previously, and it's rationalizing the denominator, part 2, because we did talk about it earlier, but this time, what if we had something like 3 over 2 plus square root of 5, right? We want to rationalize this denominator, but it's a little funky because we've got that plus 2 there. So how do we do with that? So the first step here, we're going to find what's called the conjugate radical, okay? So the conjugate radical is this. So if you have something like a plus b times square root of c, so in this case up here, a is 2, b is invisible 1, just 1, and c is 5. The conjugate radical is a minus b square root of c. So in this case, again, if we have 2 plus square root of 5, this becomes 2 minus square root of 5. Okay? So once you have the conjugate radical like this, get rid of some of that. Then what you're going to do is you're going to take your expression. So in this case, we have 3 over 2 plus square root of 5. And I'm going to multiply it on top and bottom by the conjugate radical. So 2 minus square root of 5 over 2 minus square root of 5, our fancy one. And the reason I did this is because when you look at the multiplication on the bottom, so we have 2 plus square root of 5, parentheses, 2 minus square root of 5. When you multiply a radical by its conjugate radical, something interesting happens. So let's go ahead and FOIL this out. So this becomes 3 2 minus square root 5, and then, so 2 times 2 for this first red line is 4. Then the second red line is minus 2 square root 5. And then this first blue line is plus 2 square root 5. And the second one is square root 5 times minus square root 5. It's going to be, you can do the exponent rules and all the math and such. Eventually, it works out to be minus 5. And you might notice this and this here is a minus and a plus, and these will cancel out. And so what we're left with is 3 times 2 minus square root 5, which we will distribute in a minute. But then we have 4 minus negative 5. The radical went away, right? So if you take some like 2 plus square root 5, something that looks like this form here, and you multiply it by its conjugate radical, you will get rid of the square root. Right, so then if we distribute this 3 into here for our final answer, we'll get 6 minus 3 square root 5, and then on the bottom it's 4 minus minus is plus, so 4 plus 5 is 9. And then you can actually end up simplifying this further, but this is where I'm going to stop for now because this is really the meat of the problem here. Okay? This could be simplified further though. Cool. Now, I'm going to leave you with sort of a warning on common mistakes. So, some common mistakes. As I discussed previously, if you have some fractional expression or whatever, and the denominators, in this case we have a and b, are not the same, then this is not equal to a plus b. So again, you cannot add or subtract fractional things when the denominators are different. You have to play around with them and try to make them the same, and then you can go ahead and do it. And then the other common one that I mentioned a little bit earlier is if you have something like this. So say if a plus b over a, or anything can stand for a and b, right? They can be polynomials, they can be linear factors, they can be numbers, whatever. You cannot cancel these a's to then just get b over 1, okay? That does not work. Don't do it. Don't do it. Okay? So yeah, stick with the rules. Try to avoid these common mistakes, and good luck on the homework.